Okay, let's have a look at a few examples of trig identities, and I'll give you some tips for when solving them. First off, with an identity, you're never going to be moving anything across the equals sign. The idea is not to solve for a variable, but instead to prove why the right-hand side equals the left-hand side, and, vice versa. So never try to move anything across the equals side. You can never multiply anything by anything other than a form of 1. And that will become more evident as we see more examples. But you can't multiply or divide anything by anything that changes the value of the expression, I guess would be the best way to say it. Like when you're, multiplying fractions or changing a denominator, you're not changing the value of the fraction, you're just making it easier to work with. In general, when doing identities, start with the side that looks more complicated. It'll give you more to work with, it'll make things easier, but don't always get used to having the more complicated side or the easier side to work with on the left-hand side. Sometimes on an exam or a test they will put the one that will be significantly easier to start with on the right, just because they know you're not used to it. So with that aside, let's have a look at a few examples of identities. Okay, if we see something like cosine x multiplied by cosecant x equals cotangent x, and you're asked to verify that this is an identity. Well, you see that you have two things being multiplied together that are going to give you one thing in the end. So somewhere along the line we have to have things canceling out, but we want to make this look a little bit nicer. So something that's sometimes useful to do is to write these out as fractions with their denominators, whether it be 1 or otherwise. Like we can rewrite this as cosine of x over 1 in a nice bracket, multiplied by 1 over sine x, which is cosecant of x, which we remember from our reciprocal identities, equals cotangent of x. So then we see that this is literally just cosine x being divided by sine x. So cosine x over sine x, and you can either say that this is cotangent x, or you can change this one into cosine of x divided by sine of x. Either is correct. So then we just have tangent x equals cotangent x. And this is a proven identity. Some of them that follow a similar sort of principle will just look a bit different. Like if we have a look at, for example, 4 cotangent squared x sine x tangent x equals 4 cosine x. This one, again, it's the same sort of deal. We've got 3 things being multiplied, 4 things being multiplied together that eventually just give us 2 things. They reduce down to the 4 and the cosine, so we know we have to have things being cancelled out here. So I'm just going to convert these all into terms of sines and cosines, which is another thing that's kind of helpful, especially with simpler identities. So I'm going to say we have 4 multiplied by, this is cotangent, so it's cosine squared x divided by sine squared x multiplied by sine x over 1 multiplied by sine x over cosine x, and that equals our right hand side. Alright, so right away we're going to see that the 2 signs in our numerator are going to get multiplied together and create a sine squared x, which is going to cancel out the sine squared x on the bottom. And we have a cos squared, or a cosine x on the bottom, which is going to cancel out one of the cosine x's on the top. So we can rewrite this 4 cosine squared x divided by squared x. You don't have to do this. You can go right to simplifying it further if you want. This is just kind of an extra step to really illustrate the point. Multiplied by sine squared x over cosine x Now, this sine squared x and this sine squared x are going to cancel, and this cosine x is going to take one of the cosine x's up here with it, so we're going to be left with 4 cosine x, which equals 4 cosine x, which is what our right hand side was equal to. Sometimes you'll see used for identities the notation RHS and LHS, and all that stands for is right hand side and left hand side. So which side of the equals sign you're on? This is LHS, this is RHS. And that's all that means. Let's see if I have time for another quick one. Yeah. Last we'll do a similar sort of deal. We have 3 sine x secant x tangent x equals 3 tangent squared x. So we immediately know the 3 isn't going to change. We have a 3 on both sides. We have 4 things being multiplied together to give us 2 things. So we're going to say 3 times sine x over 1 multiplied by 1 over cosine x multiplied by tangent x equals 3 tangent squared x. So then the sine x over 1 and the cosine, or the 1 over cosine x, they're going to give us tangent x. So we're going to get 3 tangent x multiplied by tangent x, which equals 3 tangent squared x. So 3 tangent squared x equals 3 tangent squared x. And that's really all that's to that.